So now we're on to
shells
and orbitals.
Absolutely.
I've got a question for you, Wayne.
What's that?
What's a shell?
Silly question, really. Yeah. So it's right in front of you.
Yeah, of course.
Crabs, shells.
You're right, Wayne. You're
shells,
right.
yeah.
So silly, but it's not a bit lost. My other bit.
Okay.
What are orbitals?
That's when you launch the crab into space. Thunderbirds are go.
Amazing. So that's that sorted then, really?
We're done, really.
Yeah. Okay. All right. Oh, Wayne.
Did you just get a tweet from OCR?
I did. It said, "Guys, chemistry. Also, stop live streaming us."
Okay, let's do that then.
Right, so we'll just cut this bit and make it look really clever.
Yeah, okay, so.
Right,
And now we're on to
orbitals
and shells.
Absolutely. So you've encountered shells at GCSE.
Yep. And you know, I've lost my pen. Did you know that?
I didn't know that, but I know that now, so it's okay, Wayne. There's a pen here. Oh, you've got one.
I've got one.
That's all right then. So shells are the things around a nucleus.
Yep. And you're aware that in the first and the second shell, there's going to be...
Well, in the first shell, there will be 2. If we draw a little thing here. And now the next one, there'll be 8.
Yep, and you probably know that from GCSE.
But it's
that
not
means
quite true.
It's 2. And 8 is normally just like that.
Because that's true for the shells, but there's also shells within the shells, and within the shells, there's orbitals.
Shellception.
No. So that's true for shells,
Yeah, there is that many electrons in the first shell.
but within each of these shells there are subshells.
Yes, and these are made up of orbitals.
And orbitals are places where electrons can be, and you can write them sort of like a box. Pen's a bit rubbish, and you write them like that.
Yep. So we've got S and P subshells.
And well, where do they come from, Wayne?
Well, they come from where the electrons are found. The orbitals is how you think about them.
But you can look at them in the periodic table.
You can indeed. So S is the first one.
Yeah.
It's spherical. That's obviously a circle. Imagine it as a sphere.
It's a sphere, and because our subshells are just areas where the electron can be.
Yeah.
We can't say it's one of those places, it's an area that it can occupy.
And up to 2 can occupy this area. So what Triv's drawn here, that on its own would be an orbital for that subshell.
Of each of the arrows facing opposite directions, it had to be opposite spins.
So we're looking for pairs. So from hydrogen to helium is just 2 electrons to complete the shell. You're aware that helium just looks like that without the outer circle.
Yeah.
So that would be 1 S subshell filled.
It would. But then you go on to the next line,
Yeah, we've got
another pair.
here,
So this would be
here, all the way down.
2s, right?
Yep, so this is 1S, 2S, 3S and 4S. That's as high as I'm going to go.
Yeah. So you can call your group 1 and 2 your S block, if you like.
Yeah, absolutely. So I'm just going to do an arrow here in red. That's your S block.
Okay. And then we have this side, we sort of skip the transition metals for now. We have all of this side where there's 6 little, there's 6 groups here.
Yep.
And this is all the P block. Now the P block's a bit different. So the P block is a P shell.
Yep.
And it's sort of like dumbbells, isn't it, Wayne?
It is, and each dumbbell can contain up to 2 electrons with opposite spins. So when they overlap in the way Triv's about to draw, there'll be 6 altogether. You see here there's 4, then there's 1 coming out. It's 3-dimensional, which is really awkward to draw. The dotted line represents the Z-axis coming out towards you. So there'll be 6 altogether.
Yeah.
And this is P2, or 2P,
Yeah.
3P, and 4P again. That's as high as we're going to go today. I'll
Yeah.
have that the other way around, 2P. And all of this, as Triv said, the 6 altogether is your P, done in blue.
Yeah. And orbitals can have 2 electrons in them. P subshells have 3.
Yes, 3 boxes each with 2 adds up to the full 6 electrons.
So I'm going to do this in blue because that's what our P is in.
Yeah, that's a good idea.
Thank you.
Poop. Blue. That's good.
Poo. Sorry, that was really childish. So we have P, then we have like stop it. And if this was this would be completely filled, and this would be one of our noble gases.
It would indeed, because it's all the way, and it fills one by one. We'll get on to filling in a bit more detail in a second.
Yeah. So these are our shells, our subshells, and then our orbitals. We've done our shellception.
Yes. We're going to get on to D's in just a second. We're going to go through a few examples of how to fill the others before we confuse you a little bit.
So they don't just fill by doing that one, and then that one, and then that one.
No.
They fill in a slightly different way, and that's got a name, isn't it, Wayne?
It's the Outfall Principle. Very
Yeah,
funny word. I'm
it
gonna
is.
write it down here.
I think it might be. Is it German chemistry? Or
It is indeed German.
Yeah, so it's Aufbau or Aufbau, however you want to say it, spelt like that. And the Outfall Principle tells you how to fill them. So your S shells, they fill how you'd expect them to fill. It does first one
Rub
of them,
some of this stuff off.
and then yeah, we don't need all of this. You should be able to remember this. And if not, just pause the video. The wonder of the internet knows no bounds.
Yet.
Not yet. So RS, it will fill like you're expecting it to first. This one.
So hydrogen, you'll get
Yep.
one electron, done. Then helium.
Yeah. And then we have our next bit. Say this is our.
So this is 2s. Oh, yeah. So it would have one, then it would have its second one if you're filling that. This is
Yeah.
2s. Then 2p.
So this is when it gets a bit more interesting.
This is where the Outfall Principle comes into play. Because as trip drawn, you've got 3 boxes, so it adds up to a total of 6 possible.
It does.
So
And the first one, it fills the first bit.
Yep, so that would be boron, I believe.
Yeah.
Then
And then it's
there's-
aluminium. No. No, sorry, I'm lying.
Yeah, it's boron. Carbon.
Yeah.
So that's next. It's going to fill up that box rather than this one with the
Yeah.
opposite spin, because that's more stable.
Because it wants one of each before it wants any more than that.
Then we go on to nitrogen, which is going to then fill up the third box. Now it can start pairing up, and that's the Outfall Principle.
Yeah.
So
There's
then,
all of them in a line before it goes into this one. Then there's this one.
and finally neon, and there you go. And that's how your p orbital fills up, and that's the Outfall Principle.
But then we have the D block.
We do. It gets a little more complicated.
So D block's full of transition metals. You don't need to know how it fills,
No, 'cause that's A2 chemistry.
but you do need to know how many orbitals it has.
Do indeed. So I know that there is. If I draw that there, this is the D block, just in
Yeah,
case you're on
the
there.
transition
You've
metals.
got a purple pen.
I have got a power pen, so
Colour
I'll use
coding
that.
it. So this here, all the way here, just in case you didn't know, is the transition elements. That's your D block,
Yeah.
and it's actually got 10 in it.
So it will have 5 orbitals.
10.
So it'll have 5 orbitals, and it doesn't matter how they fill up yet. You need to know it has 5 orbitals and 10 electrons in total.
So each orbital can hold 2 electrons off its spin. So in terms of the box, you're going to have to draw 5 for a complete D subshell to give you 10 electrons.
Yeah.
It starts here at 3D, so this is 3D. Underneath
Yeah.
it would be 4D, but you won't get asked questions on that.
And it asks you, it says 3D because it fills before 4S.
And for this, we need to express energies.
So we get to energy levels, a bit more complicated now. So as you go up our periodic table or across, the energy level increases. There's more electrons and more protons and that sort of thing. And this is to do with the distance from the nucleus.
So if we have energy up here, E,
Yeah, and this is a graph.
your 1s will have the lowest energy, because that's right at the top and it's going from left to right.
Mm-hmm.
Then it's going to go up to 2s, so it's going to require a bit more energy.
Yeah.
2p, 3s,
And this will.
3p,
Yeah.
and that's all of this up to here so far. Then we're going back to here to the 4s, 3d, 4p row. This is
Yeah.
where it gets slightly jazzy.
It's slightly jazzy indeed. So it has 4S, but then it has 3D which is below it, which then is why you fill 3D first and why it's called 3D. And then you get 4P. And it goes up like that.
And there you go. You don't need to know beyond then. It's not going to ask you above that. It's just
No.
to try and catch you out.
So that's why that fills first. You just need to know it does fill first, and these are the energy levels.
So let's briefly go through a few examples.
So if you wanted to write the electronic configuration of something that had a D subshell in,
Okay.
need a periodic table line.
OCR has got that.
It has at the back of the book, you have a periodic table, which is quite handy. And to chemistry of a formula booklet, yeah, the things you'll have in your formula booklet will be in the back as well.
Yeah, so that's handy as well. So, periodic table will pick manganese.
Okay,
It's
let's go
just
to
there.
manganese.
It's on the 3D shell across here.
Okay,
And it's 1, 2, 3, 4, 5 into it.
alright.
Okay. So what we're going to do is I'll mark it on here. 1, 2, 3, 4, 5. MN, and it wants the electron configuration. That's
Okay, does it want it in boxes or just, yeah?
We'll just do the
Letters.
normal electron configuration.
So, if you go from the very beginning, we
1s.
have 1s2.
So little 2 in the air.
Like
So
a power.
1 represents as the first of its kind, S is the kind, and 2 is how many electrons is in it. So 2 is the second S, again it's filled, it's got all 2. Then it's 2p6, because it starts at 2p,
Yeah.
and it's all 6. Then it's 3s2,
Yeah, sorry, I'm ahead of myself.
3s2, because that's full, 3p6, because that's full,
Then
then 3d5, 4s2, because that's the order it fills. However, although you need to know this, if you put 4s2, 3d5, it's accepted in the exam.
Yeah.
And it always is, that's what OCR does. But you need to understand that does fill first. Either way round is accepted if it asks you to write an electron configuration, but really, you should be doing it that way round.
But there's an easy way to write this down, isn't there, Wayne? Because this is lengthy.
If it asks you to write the entire electron configuration, if it starts you off at 1s2, which it normally does as a hint, you have to write it all out.
You have to do it like that. However, later on in chemistry or just in life, if you want to write about manganese, you don't want to write all of this out because you know if it's got to this bit, the rest is filled.
So what you can do is you can sort of have a checkpoint, but the checkpoint has to be where it's completely filled its entire shell.
So we choose our noble guesses. So for our manganese example, we choose our second noble guess, which is
Argon here. This is argon. So we put in square brackets argon, which represents all of this up to argon being completely filled.
And
argon
then
is 3p6. So what we've done is we've got rid of all of this. Argon represents that. Then we can do the 3d5 4s2.
and then that will be manganese. So that's much, much quicker.
And it's just worth shouting out, it's not just for DBlocks that you can do this with. You could do helium and then 2s1 if you were being really lazy.
Yeah, but you
You can do it with any, as long as it's a noble gas and it has to be in square brackets.
Yeah, and that's electrons, subshells, orbitals, and shells.
Stuff.
Stuff, yeah.
So ask us any questions if you need, because this is a quite lengthy video,
It's
quite a
quite
lot of
lengthy.
stuff.
Yeah.
I'm going to go get a crab from space.
I
And
think that's a
then
good idea.
McDonald's.
Yeah, definitely, yeah.
Okay.
yeah.